Hi, I'm Rich with insideHPC. We're here at SC17 in Denver, Colorado, and today we're at the Innovative Technologies room at SC17, and I'm here with Theo from Posit Research. Theo, welcome to Denver, but let's start at the beginning. Who is Posit Research, and who do you help?
Excellent. So Posit Research is a commercialization of the work that John Gustafson did on this number system that he calls universal numbers.
Oh yeah, Unum computing, Posit computing?
Unum computing, yeah. He has an incarnation that he calls Type 3 that in the vernacular would be Posits. And positresearch.com is sort of a collaboration with John's team and some other folk that tried to commercialize Posits to application developers so that they can deploy it to AI, DSP applications, and HPC applications.
Okay, so the way I understand it, this Posit computing can serve as a replacement for IEEE floating point in expressing numbers. Did I get that right?
Correct. So there's two dimensions to the benefit of posits. Sure. One is that a posit, being informationally denser, can represent an approximation, a quantization of the real numbers line with fewer bits than floats. So this saves you in memory bandwidth if your applications are memory bound, in storage if your applications generates lots and lots of data. And then the second dimension is this part that is giving you programmer control of the rounding. So it's a generalization of sort of the fused multiply add across complete dot products or even tensor products. So posits as compared to floating point is trying to sort of solve the rough edges that floating point has. As I said, it has the higher informational content, so that saves you on memory bandwidth. Also saves you on transistors in the data path because it's just a simpler data path. And then this quire, this super accumulator mechanism that gives you error control at the programming level, is that next layer where you can now produce reproducible linear algebra, which you can't really do with floating point.
Okay, so that kind of answers the question, why would I want to use Posit computing? What is your mission, Theo, as CTO?
Really the commercialization. So make a framework available for people to experiment with the Posit number system, to deploy it in their own applications, and to have a roadmap for them in which they can, when they get to that point, can get to a hardware accelerated platform.
And how would I kick the tires on this and learn more?
Excellent. Posit-research.com will be the central hub for the roadmap, the technology roadmap for this commercialization piece. John and his team in Singapore maintain a public domain website called posithub.org. And good to know that the Posit standard is always going to be open source. So anybody can go to posithub.org, find the papers and the publications and the community's open source implementations of this stuff. Ours will be there as well. So people can pick that.
People can contribute to the tree. As
well, yes. Wow. So our goal is to help John with a verification suite that he can use so that when people say, hey, we would like to implement it in our own stack, they have a verification suite to go after. And then, of course, the goal really would be to build, depending on what the community asks us to do, a hardware roadmap, a hardware acceleration roadmap that makes this stuff competitive to custom AI on a Google TPU, custom AI on Project Brainwave, but we would be a posit-based widget that tries to do it in a general purpose, community-driven way.
Okay. Well, I was going to ask you about AI. Is that the sweet spot for this, you think, at least initially?
So I'm not an AI guy. I come from an HPC background. So here's the beauty of it is, so from a computational science point of view, if you look at what Google and Microsoft have done, Google has gone to an 8-bit fixed point, and Microsoft did an 8-bit with a floating point with a 2-bit exponent. So there's clearly in these domain experts, they recognize that there is some interest in precision, like in the 8-bit fixed point, or in some dynamic range mechanisms, right? So it depends on your application, and since I'm not an AI guy, it's really hard for me to answer, is this the sweet spot? But what I can tell you is that since the Posit standard is a parameterized mechanism, you can dial in as a user the precision and the dynamic range that you want, right? Our technology stack will be sort of a synthesizable, templated mechanism. So if you want a weird 5-bit posit with a 1-bit exponent, we can build you a software stack and a hardware stack that does that, right? So the cool thing for it is, for those people in AI that would like to compete with Google and Microsoft, now they have a tool with which they can play, right? So they can do the software stack right now. You can download that from GitHub. We have the hardware running. That is still kind of rough, but our goal is there is a conference on next generation arithmetic in Singapore in March. That's where we will report all the benchmark results on the hardware, doing quires, and we're doing some really funky data types and whatnot to really push the envelope here of what is possible with a number system that is really customer oriented, right? Whatever a customer can deliver and need, we can deliver with this number system.
Well, hey, thanks for sharing that. This is really exciting. That it's near-term future. Not, I thought, oh, is this going to be like flying cars? You know.
No,
So,
this is here.
Yeah.
It's here now.